If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitwood Fort Bend Tutoring, and today we have a fantastic tutorial prepared for you today, and it deals with rewriting logarithms as a sum or difference of logarithms. That's right, we'll be writing logarithms in expanded form. We'll be expanding logarithmic expressions. And first and foremost, I would ask for you to go ahead and subscribe to Fort Bend Tutoring's YouTube channel. While you're at it, go ahead and click on the bell icon, and let's take a preview of what I have prepared for you today. That's right. We have 12 problems for you today that will deal with expanding logarithmic expressions. Check out the fact that we have, of course, your logarithms. We have your natural logarithms involved. We have logarithms with fractions involved. We have logarithms with radical notation involved. Oh, that's right. We have your square roots ready for you, as well as cube roots, fourth roots. That's right. We have everything at the ready to assist you with expanding logarithmic expressions. So here's a snapshot of the 12 problems that we'll be doing in this video, and let's go ahead and begin with a recap of your logarithmic properties and definitions. So just to remind you guys, here are a few pages of your logarithmic properties. Don't forget to check out our logarithmic properties video that we've posted on our YouTube channel in the logarithms playlist. That'll be one of the easiest ways to find it, and I'll include a link within this video so that you can access that video, so you can get a refresher over the logarithmic properties that you'll be seeing in this video. So let's just go ahead and blaze through this real quickly. Just going ahead and giving you a visual on the basic properties of logarithms that we've already discussed in that aforementioned video. That's right. So of course, in expanding logarithmic properties, we'll really be utilizing these properties a lot. So dealing with the product rule for logarithms, the quotient rule for logarithms, and of course the power rule for logarithms. Bottom line is, anytime you have a logarithm where you have two values multiplying on one another, you can expand this expression by rewriting it as a sum of logarithms. That's right. And then for this one here, for the quotient rule, anytime you have the logarithm of two values dividing, you can of course expand that using the difference of those logarithms. Yeah, that's right. And then finally, anytime you have an exponent on a value where you're taking the logarithm of it, you can rewrite it as that same value being the coefficient of the logarithm and its base. Yeah. So now that we've done a quick recap on that, yeah, let's get with problem number one. There you go. So in problem number one, we have the log of base 7 of 49k. Well, ideally, what you would like to start off with is what operation is going on overall, especially within the parentheses here. And you should notice that what's going on overall is multiplication. In fact, it's 49, that coefficient in front of the variable k, is multiplying on k. So you have 49 times k inside of the parentheses. Well, because these things are multiplying, we can go ahead and utilize that product rule in order to rewrite the expression. So utilizing the same logarithmic base, we can expand this by showing that it's log 7 of 49 plus log 7 of k. Now, because you've expanded the logarithm, that's great and all, but you're still responsible for simplifying the expression as much as possible. And according to this first term, this log 7 of 49, we're able to simplify this first term even further. So showing that we could rewrite 49 with the same base as our logarithm, we could rewrite that as log base 7 of 7 squared. And then bringing down that second term for good measure there, we can then simplify the first expression using one of our basic properties that allows us to cancel out that value of 7 as well as the base of 7 when they share the same base, and you're left with the exponent. So this exponent of 2 will come down, and we end up with 2 plus log base 7 of k. And this is going to be our result. And if you've been a follower of FBT, you know that we always put our answers in a red box. That's right. We're red boxing our answers. So our result for problem number one is going to be 2 plus log base 7 of k. Yeah, there you go. Yeah, yeah, that's problem number one. And so we'll be moving on to problem number 2. And in problem number 2, we have the natural log of e divided by 5. So this problem is set up in such a manner that we'll be using the quotient rule. So the quotient rule says that we could rewrite this as the natural log of e minus the natural log of 5. That's right. Using that quotient rule, we end up expanding the expression using subtraction. And then, of course, you're supposed to simplify your result as much as possible. So when you're looking at the natural log of e, if I were to show all my steps, I could express this as log with the base of e minus the natural log of 5. That allows me, showing that my exponent on e is 1, that this allows me to cancel this out to give me a result of 1 minus the natural log of 5. And this is the answer to problem number 2. Red boxing it. Yeah. And of course, you could have just immediately gone straight to 1 if you knew that the natural log and the e canceled out. But I wanted to give you a little bit of the why we're able to do that. You see how I hooked you up real quick with that extra step that no one's really appreciating. Problem number 3. We have log of 1/7 mn squared. Yeah, well, we have 1/7 multiplying on m, which is multiplying on n squared. So let's go ahead and expand this using the product rule. We're able to rewrite this as log of 1/7 plus log of m plus log of n squared. All right, but we're not done. Primarily because we can still simplify this problem as well as get rid of all of the exponents on our variables. And we'll do so by, first of all, rewriting this first term as log of 7 to the negative first power. And then bringing down this log of m plus log of n squared. Then all of our exponents that are not 1 will become coefficients in front of the terms. So that means I can rewrite the first term as negative log 7 plus log m plus 2 log n. So notice that I'm using the power rule in this last step here, where I'm able to bring those exponents as coefficients in front of the term. So this is our final result here for problem number 3. And of course, we will be red boxing it just like that for problem number 3. Amen, amen. Continuing on with problem number 4. With problem number 4, we'll have the natural log of a to the 4th power b divided by c to the 9th power. Yeah, that's what that says up there. I know it's kind of hard to see, but this is a to the 4th power times b divided by c to the 9th power. So overall, we have a fraction going on here, right? It's a rational expression within the parentheses. So we'll be using the quotient rule. So I'll be bringing down this natural log of the numerator, which is going to be a to the 4th power b, minus the natural log of c to the 9th power. Well, what happens here is that we realize that within the parentheses in that first term, you have multiplication going on. That means that we can continue expanding this by using the product rule. So this gives me natural log of a to the 4th power plus the natural log of b minus the natural log of c to the 9th power. And now to take care of those pesky exponents. That's right. Let's make those exponents coefficients. So we end up with 4 times the natural log of a plus the natural log of b minus 9 times the natural log of c. So you want to keep in mind that when expanding your logarithmic expressions, you want all of your variables to be to the first power. So that's another way to tell whether or not you have an additional step to do before you reach the end of your problem like we did. So we end up with this answer here, 4 times the natural log of a plus the natural log of b minus 9 times the natural log of c. And of course, we are going to be red boxing it for problem number 4. All right, let's keep things moving, guys. And let's go ahead and remind you guys that you can always set up a paid online tutorial today with FBT. That's right, Fort Bend Tutoring. So no matter wherever you are in the world, if you're English speaking, that's right, if you're an English speaking math student, then that means that you can get an online tutorial using Skype or FaceTime anywhere around the world, wherever you have internet access, of course. So go ahead and check out the website. We are at tutormemath.net. and set up an online tutorial, I would love to be your personal tutor. All right, let's go ahead and continue then, guys. We have problem number 5. And in problem number 5, we have the log of m squared plus n divided by 100. Well, what do you do in this scenario? Well, first of all, you recognize that your value inside the parentheses, which you're trying to take a log of, is a rational expression, aka a fraction. Therefore, we'll be using the quotient rule for logarithms. So we're going to rewrite this as the common log of the quantity m squared plus n. Notice that we had multiple terms in the numerator. Since the terms in the numerator weren't multiplying together, you have a binomial. You need to place that binomial within parentheses when you're expanding this value. And this is going to be minus the common log of 100. Once again, you're responsible for simplifying all of the terms in your expanded expression for expanded form of a logarithmic problem. You're going to rewrite this as log of m squared plus n, and we can show, because our base of common log is 10, we can rewrite 100 as 10 squared. From here, we'll be going ahead and bringing down our first term, which is the common log of m squared plus n. And then we'll be able to simplify this last term. In other words, that common log and the base 10 will cancel out because they share the same base, and you'll end up with the exponent 2. And this is your answer. You cannot do anything further with this result. Therefore, go ahead and red box it just like that. And that's problem number 5, guys. Oh, yeah. Problem number 5. Continuing on, we have problem number 6. This is going to be log base 2 of the quantity z cubed divided by xy to the 5th power. So once again, we have a rational expression here. We're going to be expanding this, noticing that the base of the logarithm is going to be 2. So we have log base 2 of the numerator, which is z cubed, minus log base 2. Mind the fact that your bases must remain the same. So because we start out with base 2, every term with a logarithm will also have that base of 2. So this is going to be log base 2 of the quantity xy to the 5th power inside the parentheses there. Continuing on, you'll be bringing down that log base 2 of z cubed minus, and I'm going to go ahead and open up a set of brackets here because I'm going to expand the values inside the parentheses here because they're multiplying. We'll be using addition when we expand this. So we'll have log base 2 of x plus log base 2 of y to the 5th power, just like so. Yeah, just like that. And this ugly number right here is a 5. Yeah, it's a 5. Oh, you want me to fix it? Okay, let's see if we can do something with this 5 here because it's ugly. Oh, and that's not much better, but oh no, I should have just left it alone. All right, so we're gonna stick with that 5 right there. Great, thanks. And now, guys, what we'll be doing is distributing this negative here. So I got my arrows popping. Okay, just in case you thought I wasn't going to say that this video, we'll go ahead and bring down this log base 2 of z to the 3rd power minus the log base 2 of x minus log base 2 of y to the 5th power. And now we'll be taking care of all of those pesky exponents. That's what we'll be doing, making each and every one of them coefficients. So we can rewrite the first term as 3 log base 2 of z minus log base 2 of x minus 5 log base 2 of y. Red boxing it. There you go. Problem number 6. Done and done. Let's continue on with problem number 7. We have the common log of 10 divided by the square root of a squared plus b squared. That looks fun. Yeah, let's go ahead and start out by realizing that overall inside the parentheses we have a rational expression. Therefore, we'll go ahead and start with the quotient rule. So we'll have the common log of 10 minus the common log of the square root of a squared plus b squared. Then, realizing that we have basically log base 10 of 10 to the 1st power, and I can also rewrite our second term by using parentheses here and writing this term in exponential notation. That's right. So instead of using the radical notation that we were given, we're going to continue expanding and simplifying this expression by rewriting the radical in exponential notation. That's right. So we rewrote it as a squared plus b squared raised to the 1/2, being as though I have a base of a squared plus b squared to the first power underneath this radical sign here, and our root is 2. So now using our properties, we know that these 10s will cancel out to leave us 1 as a result, minus, bring this exponent, that pesky exponent, bring that down as a coefficient, so you'll have minus 1/2, and then your logarithm, the common log of a squared plus b squared, and done. There you go. That's it. This answer right here is done. Yeah, that's our result. Let's go ahead and red box it. Red boxing it. All right, let's keep it moving. In problem number 8, we have the log of base 5 of the cube root of x times the square root of 5. Yeah, that's what we have. And so we're going to start out by rewriting the initial expression with parentheses here and exponential notation. We'll say that we have that radicand, that x times the square root of 5, raised to the 1/3 power. That's going to be our first step. All right, in expanding our expression. From here, we can bring down this 1/3 exponent as a coefficient to say that we have 1/3 times log base 5 of x times the square root of 5. Just like that. And then we'll go ahead and use our product rule. So I'm going to start by showing that we have 1/3. Using a bracket to expand this, we'll have log base 5 of x plus log base 5 of the square root of 5. Then we'll have our 1/3, and this is going to be times the log base 5 of x plus log base 5 of 5 to the 1/2 power. So notice that I'm rewriting our radical notation of square root of 5 into exponential notation as 5 to the 1/2 power. Now, continuing on, we'll have 1/3 times log base 5 of x plus, and then over here with the second term, that log 5 and 5 will cancel out to give you 1/2. Yes, it will. Yes, it will. And then we'll distribute the 1/3. In other words, we'll get our arrows popping here, and you'll end up with 1/3 log base 5 of x plus multiplying 1/3 times 1/2 will give you 1/6. So this is going to be our result here for problem number 8. You end up with 1/3 log base 5 of x plus 1/6, and we're going to put a red box around our answer. Done and done for problem number 8. So check out all of the conversions that we did here. We started out by converting our initial cube root into exponential notation. We did that by raising that radicand to the 1/3 power. Then we took our exponent and using the power rule, we made it into a coefficient. So we have 1/3 log base 5 of our value of x times the square root of 5. Then because we have multiplication going on within the value, we expanded that using our product rule, brought down our 1/3 here, and was able to expand that expression using the product rule. Then because we have our square root of 5 here, we wanted to rewrite that in exponential notation. We went ahead and simplified that using one of the basic properties of logarithms there. And then we distributed. We got our arrows popping. Yeah, we did. And we ended up with our result here, which is 1/3 log base 5 of x plus 1/6, and done. Don't forget that red box. Problem number 9, guys. Problem number 9. We have log base 5 of the cube root of 25 divided by a squared plus b squared. So how do we go about solving this problem? Well, first of all, I want to take care of that cube root. How? We'll go ahead and say that we have the quantity of 25 divided by a squared plus b, which is being squared, by the way. We're going to raise all that to the 1/3 power. Then we'll bring that 1/3 in front. So we have 1/3 log base 5 of 25 divided by that quantity of a squared plus b, which is raised to the second power. And then because we have that 1/3 multiplying on this log base 5 with a fraction, we'll go ahead and use the quotient rule, and we'll have 1/3 times log base 5 of 25 minus log base 5 of the quantity a squared plus b squared. Just like that. Next, we'll be rewriting this as 1/3. With the first term, I can go ahead and simplify this by showing that 25 is equivalent to 5 squared. I know I would want to bring this exponent of 2 in front of the second term within the bracket. So this is going to be 2 times log base 5 of the quantity a squared plus b. Remember with that binomial You can't do anything with it. All right. So just leave it inside the parentheses. Just let it chill for a second. Okay. There you go. Let it marinate. There you go. We're going to go ahead and simplify that log base 5 and 5. Those will cancel out. You'll have the 1/3 times 2 minus 2 log base 5 of a squared plus b. All right, just like that. And from there, we'll go ahead and distribute that 1/3. So distributing the 1/3, it'll look like this. All right, we'll be getting our arrows popping here, guys. So you have the 1/3 times 2, which will give you 2/3, minus 1/3 times 2 log base 5 of the quantity a squared plus b. That'll give you a negative 2/3 log base 5 of a squared plus b. All right, and this is your answer right here. Yeah, it's done now. Can't do anything else with that. Red boxing it. Just like that, guys. That was problem number 9. And now let's move on to problem number 10. With problem 10, we have log of the cube root of the quantity x plus y squared divided by 10. Well, we have another cube root. Well, what are we going to do with that? Same thing. You have your common log here. You can rewrite this as a quantity of x plus y squared divided by 10 raised to the 1/3 power. Bringing that exponent in front as a coefficient, you'll have 1/3 log of the quantity x plus y squared divided by 10. Just like that. Because we have a fraction inside of the parentheses, a rational expression, you'll go ahead and rewrite that using the quotient rule of logarithms. So we'll have 1/3 times the common log of x plus y squared minus the common log of 10. Like so. Then we can simplify within the brackets. We'll have 1/3 times the log of x plus y squared minus 1. How do we get that 1? Remember, common log has a base of 10. This 10 is to the first power. Therefore, these will cancel out to give you 1 inside of your brackets for the second term there. Then we can show that we have 1/3 times 2 times the log of x plus y minus 1. Then you can get your arrows popping here and distribute that 1/3 to end up with 2/3 log of x plus y minus 1/3. And this is your answer for problem number 10. Red boxing it. That's what's up. Let's continue moving. For problem number 11, we have the natural log of the cube root of xy divided by wz squared. So let's go ahead and set this up. Using the quotient rule, we'll have the natural log of the cube root of xy minus the natural log of wz squared. From here, we'll go ahead and rewrite the first term as the natural log of xy raised to the 1/3 power. Then with the second term, I'm going to expand this using the product rule. So we'll have the natural log of w plus the natural log of z squared. Notice how I left that minus sign on the outside of the brackets there so that I can properly distribute it later in the problem. We're going to bring down this 1/3 here as a coefficient. So you'll have the 1/3 times the natural log of xy minus, within the brackets, we'll go ahead and show that that exponent can come down as a coefficient. So we'll have 2 times the natural log of z. At this point, we'll go ahead and show that the x and y can be expanded using the product rule. So we'll have the 1/3. This becomes the natural log of x plus the natural log of y minus our quantity of the natural log of w plus 2 times the natural log of z. From here, we're going to get our arrows popping. That's right. So I'm distributing that 1/3 inside the first set of brackets there, distributing that negative inside of the second set of brackets, and we end up with 1/3 times the natural log of x plus 1/3 times the natural log of y minus the natural log of w minus 2 times the natural log of z. There it is. Red boxing it. Oh, yeah. I mean, we're just having fun with this today. That's all we're doing. That's all. It's in a red box. Let's keep it moving. With problem number 12, we have the natural log of the 4th root of a squared plus 4 divided by e to the third power. Now, this root is going to be over the entire expression here, okay, just to let you know. This fourth root's radicand includes the e to the third power. So when we rewrite this, we'll go ahead and show that this is the natural log of a squared plus 4 divided by e cubed raised to the 1/4 power, like so. Then we'll bring down that 1/4 as a coefficient, and we'll have the natural log, of course, of a squared plus 4 divided by e cubed. Then from there, we'll rewrite this as 1/4 times the natural log of the numerator, which is going to be a squared plus 4, minus the natural log of the denominator. So that's the natural log of e cubed there, and that will complete our brackets. Now we'll simplify within the brackets. So I'm bringing down the 1/4. We'll have the natural log of the quantity a squared plus 4, and we're able to simplify the natural log and the e just to give us a result of 3, and then I'll distribute that 1/4. So that means I got my arrows popping here. Okay, so you'll have 1/4 times the natural log of the quantity of a squared plus 4 minus 3/4, and this is going to be our result right here. Red box in it. So your result for problem number 12 is going to be 1/4 times the natural log of a squared plus 4 minus 3/4. Well, ladies and gentlemen, that's going to conclude our video for the expanded form of logarithms. That's right, writing a logarithmic expression as a sum or difference. And as always, please rate, comment, and subscribe. This is Mr. Witt with Fort Bend Tutoring. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.